Alright, this is my Unit 5 MCQ test corrections. So, I got a 4 out of 8 on the MCQ part. Number 1 is... Okay, so 2 carts of masses 1 kilogram and 2 kilogram travel together. As shown in figure 1, at time t equals 2, a compressed spring inside of the 2 kilogram cart expands, and the carts separate. Figure 2 shows a graph of the cart's velocities as a function of time. What is the magnitude of the change in linear momentum if any of the 2-cart system between t equals 0 and t equals 4? So in this question, okay, so we see that we can just look at the graph and solve this. When the 2 carts are traveling together, they have a mass of 2 and 1, 2. It can be rewritten as 1 since they're together, but I just chose to write them as 2 separate things going at the same speed, but they're technically connected. And that's equal to, when they're separated, mv plus mv. And you can see on the graph that they'll go 2 times 2.5 and 1 times 1. And both of these will be equal to 6, which means that the momentum didn't change at all. So that's why the change in linear momentum is 0. Because before the collision, before the spring compressed, it was 6, and after it compressed, it was still 6. So momentum was conserved. All right. This one, a student performs an experiment in which a 4 kilogram object travels across a horizontal surface with initial speed velocity 6 meters per second, and 2 kilogram object travels across a horizontal surface negative 3 meters per second. So these 2 objects are moving together. One's moving this way and one's moving this way. So may I answer that the position of the center of mass would remain constant? Doesn't work in this situation because the center of mass will always be approaching kind of like the middle between the 2, depending on where the center of mass is. So the reason why d, the velocity of the center of mass of the 2 object system, remains constant during the experiment makes sense, is because the objects are traveling at a constant speed. One is traveling 6 meters per second, the other is traveling negative 3 meters per second. In this situation, we're assuming that there's no, I guess, sort of acceleration. Everything's a constant speed. And so when they bounce off, they'll still be at the same speed, so the velocity will remain constant of the center of mass. The velocity of the center of mass will remain constant in this question. So that's why the answer is D. Okay, this one, on a straight horizontal track along which blocks can slide with negligible friction. Block 1 slides towards block 2, which is initially at rest. Force probe. Okay, so this one. Okay, so first you have to understand that a force versus time graph, the area under that curve will get you change in momentum, which is also called inertia. And so since you have that, because of the electronic force probe, that's all you need to determine the change in momentum of block 2, because inertia is change in momentum. So yeah. Let's see. Okay, last question. Number 7. Okay. Yeah, 2 objects moving towards each other, object X and Y. The kinetic energy of object X looks like this. So it has a decrease in kinetic energy. So we're assuming in this question energy is conserved. So if object X has a decrease in kinetic energy, then object y will have an increase in kinetic energy, because if one because one just can't lose energy like that. It has to be transferred onto the other object if it's in a collision. So it had to have been transferred to object y, and that's why the answer is A, that the velocity y after the collision is greater than it was before the collision. This makes sense because if you have an object that's like maybe heavier, or it can either be heavier or moving faster, the object that has more momentum will transfer some of that momentum into the other object, and it'll make the other object go faster.